Bismillahirrahmanirrahim. Our lecture today is about the meninges of the brain. What we mean by meninges? The meninges actually is the plural of meninges, and the meaning of meninges is a membrane. The term meninges encompasses a group of three membranes that provide mechanical protection and support to the delicate tissue of the central nervous system, let's say the brain and spinal cord. So its functions or its benefits are a mechanical protection and support to the brain and spinal cord. Where is this meninges present? Moving inwards from the skull towards the brain, from outside to inside, or from the vertebral canal toward the spinal cord, from the inner surface of the vertebral canal towards the spinal cord. These three layers or three meninges are the dura mater, the arachnoid mater, and the pia mater. This picture shows you these three layers. The first layer is the dura mater, and it consists of two layers. The second is the arachnoid mater, al-ankabut here. The meaning of mater is mother, al-um. So the dura mater, al-um, al-jafiya. Second, we have the arachnoid mater, al-um al-ankabutiyya, and is called arachnoid. Arachnoid means spider, ankabut, because of the presence of multiple trabeculae that attach this layer to the underlying layer. This trabeculae give the appearance of this layer just like a spider, so it is called arachnoid mater, al-um al-ankabutiyya. The third layer, which is in close relation to the brain tissue and spinal cord, of course, is called, it's a very thin layer, is called the pia mater. The pia mater, al-um al-hanun. We will discuss these three layers. We give you short notes about these three layers, starting with the dura mater. The dura mater consists of an outer layer which is rich in blood vessels and nerves, and it's attached to the inner surface of the bone of the skull, and is called the periosteal layer, and an inner layer which is called a meningeal layer. So the dura mater consists of two layers. Outer layer is called periosteal layer, and the inner layer is called the meningeal layer. These two layers at some sites within the skull are separated, forming channels for blood draining from the brain into the veins, and these channels are called dural venous sinuses. For example, we have many dural sinuses, and we will discuss in a separate lecture later on. We will discuss these dural venous sinuses. So how it is formed, these dural venous sinuses? It is formed by separation of the two layers of the dura mater at certain situations within the cranial cavity. When it is separated, it will form the dural venous sinuses as you see in this picture. So this is the dura mater. This is the two layers fused together, but here in the upper part of the cranial cavity, in the midline, these two layers, the periosteal layer and the meningeal layer, here it is separated, forming this sinus. This is space containing blood, venous blood, just like vein, but the wall is composed of the layers of the dura mater. Of course, it is lined by epithelial cells, just like the veins, because as you know, the blood cannot move in this space unless it is lined by an epithelial cells, just like the lining of the vein. So here the two layers of the dura mater separated to form this sinus, which is one of about 12 to 14 sinus present in the cranial cavity. All these sinuses are formed by separation of these two layers, the periosteal and the meningeal layers. And of course, in this picture, this sinus is called the superior sagittal sinus. The superior sagittal sinus. We will discuss these sinuses later on in a separate lecture, inshallah. Okay. The dura also extends into membranes. Extends into membranes that subdivided the cranial cavity into compartments, and of course each compartment contains part of the brain and other structures. The central vertical extension of this dura mater, it extends in the central part of the cranial cavity between the two hemispheres, between the right and left hemisphere of the brain. And this extension or this membrane of dura mater is called falx cerebri. Here show in this picture this extension as a membrane separating the right hemisphere from the left hemisphere. This is one of the extension of the dura mater, and of course we have another sides of this membranous extension of the dura, and of course this is called the falx cerebri. Falx cerebri. And another extension or another membranous extension of the dura is called the tentorium cerebelli. Tentorium cerebelli is a tent, just like a tent خيمة, which is just like a tent stretched over the cerebellum فوق المخيخ, forming the roof of the posterior cranial fossa, which contains the cerebellum and the brainstem. The free front margin of the tentorium cerebelli fits closely round the back of the brainstem. You see in this picture, yes, this is, of course, as we said, this is the dura mater. Separated, its two layers separated here and again return to unite again after forming this space, which is called the sinus, dural venous sinuses. And of course, this is in the superior part of the cranial cavity, so it is superior sagittal sinus. Superior sagittal sinus here. And after forming this sagittal sinus, the two layers of the dura mater fuse again to form this membranous part of the dura, separating the right from the left hemisphere. Separating right of hemisphere. At the lower part of this membrane, also there is separation of the two layers of this. Here, of course, we have the meningeal only, the meningeal layer folded here, forming this membrane, and forming this another space here, which is called the inferior sagittal sinus. The inferior sagittal sinus. And this dura mater form a tent-like here. This is just like a tent, just like خيمة, separating the cerebrum above from the cerebellum below. So this is called tentorium cerebelli, separating the cerebrum from the cerebellum, so forming just like a roof over the posterior cranial fossa. And here we have another membranous extension. This is small membranous extension. Also, this is called falx cerebelli, and this falx cerebelli separate or pass between the right and left cerebellum. So the falx cerebri separate the right and left cerebrum, and the falx cerebelli is passed between the right and left cerebellum. So these are the membranous extension of the dura between the parts of the brain and the cranial contents, forming multiple compartment, upper compartment containing the right and left cerebrum, and lower compartment containing the cerebellum and the brain stem, جذع الدماغ. And also, of course, here another membranous extension covering the sella turcica. You know, the sella turcica is in the upper part of the body of the sphenoid bone. This is the sphenoid bone. And here we have the sella turcica containing the pituitary gland. And this is the stalk of the pituitary gland that attached to the hypothalamus above. So this diaphragmatic structure of the dura mater covering the sella turcica and is pierced by the stalk of the pituitary gland to be attached to the hypothalamus. The blood supply of the dura, of course, you know, this thick tissue needs blood supply. From where the blood supply come to this covering of the brain, the dura, we have the middle meningeal artery. And you know, the middle meningeal artery is a branch of the first part of maxillary artery. This meningeal artery passes vertically between, if you remember, between the roots of the auriculotemporal nerve and enters the middle cranial fossa through the foramen spinosum. The position of this middle meningeal artery between the dura and the bone of the skull, as you know, it passes in close relation and has a groove within the squamous part of the temporal bone and parietal bone. So at this side, because it is close to the bone or the skull bone, any trauma أشدة خارجية to this area, to the temporal region or squamous part of the temporal bone and the parietal bone, if there is any external trauma, this artery, because it has a close relation to the bone, this artery may rupture and may cause bleeding between the dura mater and the skull bone and forming an epidural hemorrhage. This hemorrhage, collection of blood between the dura and the bone of the skull, is called epidural or extradural. Epi يعني فوق, or extradural يعني خارج الديورا, between the dura and the skull bone. Of course, this is an emergency, and the patient will need an urgent neurosurgical operation and to evacuate this hemorrhage. The dura of the brain is in continuation with the dura of the spinal cord, which is separated from the periosteum, the covering of the vertebral bones, by a narrow epidural space. This dura mater, of course, it will extend in the vertebral canal to enclose or to envelop the spinal cord also. Not only the spinal cord, even the spinal nerves. So this is continuous. The dura of the brain is continuous with the dura that enclose the spinal cord. Here, this picture will show you, this is the maxillary artery, which is one of the termination of the external carotid artery. You know, the two terminal branches of the external carotid artery, we have the maxillary artery and we have the superficial temporal artery. So the first part of maxillary artery, will give us the middle meningeal artery, which enter the cranial cavity, which enter the middle cranial fossa through a foramen, is called foramen spinosa. Of course, once it enters the skull, there is a small or a shallow groove within the squamous part of the parietal bone, and here the artery will be present between the bone and the dura. Any fracture, any trauma and causing fracture to this bone will cause damage to this artery here, and the blood will accumulate at this area, causing pressure on the brain. And of course, the treatment should be urgent surgical treatment to evacuate and remove all the collected blood from this area. The second layer, or the second membrane, is called the arachnoid matter, العنكبوتية. The arachnoid matter surrounds the brain, and here it bridges all the sulci. It bridges all the sulci. It would not enter the sulci, and you know the sulci and they are furrow مثل خاديد in the surface of the cerebral cortex. It bridges it not enter the sulci, and also the spinal cord and the cranial and spinal nerves. So it surrounds, the arachnoid matter surrounds the brain and the spinal cord and the cranial and spinal nerves. The space between the arachnoid and pia matter is called subarachnoid space. تحت. Subarachnoid space. And this space, subarachnoid space, contains the cerebrospinal fluid, النخاع الشوكي, which drains out of the cerebral ventricles. Of course, not only the cerebrospinal fluid, but also it contains the major blood vessels that supply the brain and the brainstem. So this space containing the CSF and blood vessels. The space is narrow above or over the convexity of the brain and wider below and around the brain stem. The subarachnoid space contains arteries and veins. The main arteries and veins that supply the brain pass floating in the CSF in this subarachnoid space. Of course, the subarachnoid space is continuous with the cavities of the cerebral ventricles. You know, in the previous lectures, or I think before many lectures actually, when we talk about the ventricles of the brain, if you remember, we said that we have four ventricles. We have two lateral ventricles and third ventricle and the fourth ventricle. Also, these ventricles, in the next lecture we will talk about it in details. So the subarachnoid space is continuous with these cavities, with these ventricles. This continuation, there is the fluid pass from here to here, from the subarachnoid space to the ventricles. Actually, the fluid, the cerebrospinal fluid, is formed within the ventricles by a choroid plexus, which is a plexus of cells that form the CSF. So there is a continuation, connection between the subarachnoid space and these ventricles. The third layer is the pia mater, al-Hanun, and it is the innermost meningeal layer. It is closely applied to the surface of the brain tissue and carries many small arteries and veins. It is highly vascular. The pia and arachnoid matter follow the branch of the surface of blood vessels where they penetrate the brain tissue. So this the previous notes was about the three layers of the meninges, and as we said, it's composed of the dura mater, and dura mater consists of two layers, and the arachnoid and the pia mater. That's in short actually about these layers. Now we talk about the blood supply of the brain. There are two paired arteries which are responsible for the blood supply to the brain. We have first the vertebral arteries and the internal carotid arteries. These arteries arise in the neck and ascend to the cranium. This is the vertebral artery, which is a branch of the subclavian artery. The first part of subclavian artery give us the vertebral artery, of course, one on each side, right and left. And as you know, the vertebral artery pass through the foramen in the transverse process of the cervical vertebrae. And if you remember, it passes through the foramen in the transverse, the sixth cervical vertebrae, and ascend upwards to enter the cranium through the foramen magnum. And also we have the internal carotid artery, which is a branch of the common carotid artery. And here, of course, in the right side, it arises from the brachiocephalic trunk. Here, it divides into external and internal carotid artery. and also it passes to the midocranial fossa through the carotid canal, as I will discuss or show you in the next pictures. Within the cranial cavity, the terminal branches of these arteries form an anastomotic circle. راح تدخل عندنا these vessels, the two vertebral vessels, arteries, and the two internocoid arteries, will enter the skull, and within the skull, it will give many branches, and the terminal branches of these arteries will form an anastomosis, and this anastomosis is in the form of a circle, under the brain, under the cerebrum, and the lower part of the brain tissue. And this circle of arteries, هذه الحلقة من anastomosis اللي يصير in the under surface of the brain, has a name which is called circle of Willis. Circle of Willis. We will discuss it later on, inshallah. From this circle, branches arise which supply the majority of the cerebrum and other parts of the CNS, such as the pons, medulla oblongata, and spinal cord, are supplied by smaller branches from the vertebral arteries. See? So these two main arteries, which are the vertebral artery and the internocoid artery, of course it's in the right side, and from the other side, from the left side, once they enter the cranial cavity, the middle cranial fossa, the under surface of the brain, it will form a circle-like of anastomosis, and this circle of anastomosis is called the circle of Willis. From this circle of Willis, many branches will supply the brain, the cerebrum, and the other parts, brainstem, also supplied mainly by the vertebral arteries. Okay, this is the internal carotid artery, of course. This is right, this is and left, and here is the anastomosis. This is from the vertebral arteries from behind, entering this. This picture also is clear. This is the vertebral artery passed to the under surface of the brain. Here it passed and giving branch, many branches. We will discuss it later on. And these branches, it anastomose with each other, forming this circle, which is called circle of Willis, which is very, very important here, because you know the blood supply of the brain is very important. And here, if this site is closed, or even if there is obstruction here, this area the blood will reach this area, can be reached from the other side through this circle. So if there is deficiency of blood here due to obstruction, due to thrombosis, to any pathology in these vessels, the circle can partly supply that area which is deficient in blood. Now, we talk about the internocoid artery and its course and how it reached the cranial cavity. The internocoid artery, of course, it originates at the bifurcation of the left and right common carotid arteries. And this bifurcation is at the level of the fourth cervical vertebrae. At the level of the fourth cervical vertebrae, the common carotid artery will be bifurcated to external and internal. And as you know, the internal carotid artery give no branch in the neck. The two internal carotid arteries move superiorly within the carotid sheath and enter the carotid canal of the temporal bone to appear in the middle cranial fossa to the foramen lacerum. Here انتبه عليه هنا. The internal carotid artery will ascend superiorly to reach the under surface of the temporal bone, and here there is an opening or canal which is called carotid canal. The internal carotid artery passes through this canal, but it moves slightly anteriorly to enter the midcranial fossa through foramen which is called foramen lacerum. It is not direct. The carotid canal is not passed directly from outside to inside of the cranial cavity. No. The artery will pass in the canal, and this canal has slightly anteriorly, in anterior direction forward for a short distance, and then the artery will curve to enter the middle cranial fossa, also within the temporal bone, through foramen which is called foramen lacerum. Once in the cranial cavity, the internal carotid pass anteriorly through the cavernous sinus. You know, the cavernous sinus is one of the venous sinuses within the cranial cavity, and it lies, these cavernous sinus, we have two to spare, one on the right and one on the left. And this sinus is located small space containing blood, venous blood, at the lateral side of the body of the sphenoid bone, just below the sella turcica, on the sides of the sella turcica. On the right and on the left side of the sella turcica, we have this cavernous sinus. So the internal carotid artery, when it enters the middle cranial fossa through the foramen lacerum, it will enter the cavernous sinus. And then it leaves the cavernous sinus. Distal to the cavernous sinus, outside the cavernous sinus, each internal carotid artery gives rise to the following branches. So after it leaves the cavernous sinus, the internal carotid artery, it gives many branches. What are these branches? The first branch of the internal carotid artery is the ophthalmic artery. And all of you know the course of the ophthalmic artery and its branches. When we talk about the oral cavity and blood supply to the muscles, we mentioned this artery, this ophthalmic artery at that time. So the ophthalmic artery supplies the structures of the orbit, of course, the muscles, the eye, and so on. And also it gives within the orbit many branches. Just to remember, I write it just to remember it, don't forget. It will give the posterior ethmoidal artery, anterior ethmoidal artery, nasociliary artery, of course, even central retinal artery, and the central retinal artery, very important, to supply the retina of the eye, الشبكية، شريان الشبكية المركزي. وينتهي عندنا الophthalmic artery. It ends to and leave the orbit as a supraorbital and supratrochlear branch. You remember this? Okay. Of course, the ophthalmic artery, it enters the orbit through the optic canal with the optic nerve. So this branch is the first branch given by the internal carotid artery. The second branch of the internal carotid artery is the posterior communicating artery. The posterior communicating artery. And this acts as an anastomotic connecting vessel in the circle of Willis. I will show you in the next pictures this artery and its location. So the second artery or the second branch of the internal carotid artery is the posterior communicating artery, and as we said, it acts as an anastomotic or connecting vessel in the circle of Willis. The third branch is the anterior choroidal artery, and this supplies the choroid plexus of the lateral and third ventricles of the brain, and also supplies structures in the brain important for motor control and vision. I would say it supplies the optic tract القناة البصرية. هذه is عبارة of tract of nerves. And these nerves very important, of course, and supplied the nerve also need a blood supply supplied by this anterior choroidal artery. And of course, the choroid plexus is a plexus of cells that present in the lining of the lateral ventricles of the cerebrum and also the third ventricle. These ventricles of the brain contains in its lining layer contain this choroid plexus, and of course the function of this cells of this plexus of cells, which is called choroid plexus, is responsible for the formation of the cerebrospinal fluid. يعني cerebrospinal fluid سائل النخاع الشوكي يتكون داخل تجاويف السيريبروم اللي هي طبعا اللاترال both right and left, and also in the third and fourth ventricles. هنا يتكون عندنا ال CSF from this choroid plexus. So this artery is very important, supplying these areas. The fourth artery is the anterior cerebral artery. Anterior cerebral artery, and of course this supplies part of the cerebrum, the anterior part of the cerebrum. Because the anterior cerebrum the anterior part of the cerebrum, which is mainly the frontal lobe, of course. 5, we have the internal carotid artery, then continues as the middle cerebral arteries, which supplies the lateral portions of the cerebrum. So these are the branches of the internal carotid artery, which is very important. You should remember it very well, because we will discuss later on the circle of Willis, and these arteries will constitute parts of this circle. So first of all, عندنا ophthalmic artery, and second artery is the posterior communicating artery, and third one is the anterior choroidal artery, and we have the anterior cerebral artery, and the continuation of the internal artery, it ends as middle cerebral artery. This branch, or these two carotid internal carotid arteries, right and left, with their branches, are called the internal carotid system or the anterior system that supply the brain. That means that the brain is supplied by two systems. This is the anterior system, which is also called the internal carotid system. Of course, because from its name, because the blood supply comes from the internal carotid artery, so it is called the internal carotid system. But this picture shows you the course of the internal carotid artery. Here is the carotid canal. It enters the middle cranial fossa through the carotid canal, the buttress bone, and it leaves the canal through foramen lacerum, and then it goes to enter the cavernous sinus, within the cavernous sinus, and after it leaves the cavernous sinus, it gives its branches. Now we talk about the vertebral arteries and its branches. The right and left vertebral arteries arise from the first part of subclavian arteries. If you remember, when you talk about the major blood vessels of the neck, and I draw for you the major arteries starting from the aorta. And if you remember that in the right side we have from the trunk or from the arch of aorta, we have the right brachiocephalic artery. And this brachiocephalic artery in the right side will give us the common carotid artery and the subclavian artery. While in the left side of the neck, the common carotid artery arises separately from the arch of aorta, and lateral to it, the subclavian artery also arises separately from the arch of aorta. This is different in the left from the right side. In the right side, we have common trunk, which is called brachiocephalic trunk, which gives us the right subclavian artery and the common carotid artery. But in the left, the common carotid artery and the left subclavian artery arise separately from the arch of aorta. So, the two vertebral arteries, the right and left, arise from the first part of the subclavian artery. Okay? And these arteries are ascend upwards medial to a muscle which is called anterior scalene muscle, one of the muscles of the back of the neck, which arise from the transverse processes of the vertebrae. So these arteries, the right and left, ascend upwards medial to this muscle, which is anterior scalene muscle, and they enter and they ascend they ascend, as I said, in the posterior back or the posterior aspect of the neck through a foramen in the transverse processes of the cervical vertebrae. You know, we have 7 cervical vertebrae. All the 7 cervical vertebrae have transverse processes have a small or it has a foramen or holes or foramen. And the vertebral artery will pass through these opening or foramina in the transverse processes, starting from the 6th cervical vertebrae, not 7, the 6th. It enters the foramina in the transverse processes starting from the sixth cervical vertebrae and ascend upwards to enter the cranial cavity through the foramen magnum. Within the cranial cavity, some branches are given off. The vertebral artery, once it enters the cranial cavity, it gives branches. What are these branches? Number one, we have the meningeal branch. Of course, it supplies the meninges in that area, in this area. Supplies the falx cerebelli, which is a small sickle-shaped fold of dura mater projecting forwards between the two cerebellar hemispheres. Falx, this means sickle-shaped, مثل منجل, like منجل. And as I said in the beginning of my lecture, the falx cerebri is one of the membranous folding of the dura mater, and this fold this fold separate the right and left part of the cerebellum. So this falx cerebri is supplied by a small branch from the vertebral artery, which is called meningeal branch. The second branch of the vertebral artery is the anterior spinal artery. Anterior spinal artery, which branch from each vertebral artery and unites to form a single anterior spinal artery and descend along a fissure or a sulcus in front of the spinal cord. So from each vertebral artery, from the right and from the left, from each one branch or a small artery descend and unite together from the right and left to form a single artery, and this single artery descend along the anterior aspect of the spinal cord, giving a blood supply to the spinal cord, to the anterior two-thirds of the spinal cord. The third branch is the posterior spinal arteries. Here we have two arteries. Each vertebral artery will give us single spinal artery, posterior spinal artery, and these two arteries descends along the posterior aspect of the spinal cord, giving a blood supply to the spinal cord or to the posterior third of spinal cord. The other branch is the posterior inferior cerebellar arteries. انتبه هنا. Posterior inferior cerebellar arteries, which is also تختصر PICA, P-I-C-K. So the fourth branch is the posterior inferior cerebellar arteries, and of course these arteries will give a blood supply to the inferior aspect of the cerebellum, the inferior aspect of the cerebellum. After giving rise to these branches, the two vertebral arteries converge to form a single artery, which is called a basilar artery. A basilar artery at the junction of the pons and medulla oblongata. So as it descends, these two arteries, as it descends upwards and anteriorly, the two arteries unite, join each other, where at which point? At the junction between the pons and the medulla oblongata. Here in this area, they form a single artery, which is called the basilar artery. And of course, this extends in front of the brainstem in the midline in a sulcus which is called a basilar sulcus at the ventral aspects of the bones. The ventral aspects of the bones, if you remember the models in the laboratory, we have the brain, we have the cerebrum, and below the cerebrum, we have starting the midbrain, and then the pons, and then the medulla oblongata, and the continuation of the medulla oblongata is the spinal cord. At the ventral aspect of the pons, we have a sulcus, which is called basilar sulcus. Here, the basilar artery extends upwards and forwards to ends at the junction between the pons and the midbrain. By dividing the terminal branch of this basilar artery, they are the posterior cerebral arteries. So the basilar artery gives many branches, but its terminal two branches given at the level of or at the junction between the pons and the midbrain. And these two terminal branches are the posterior cerebral arteries, that say right and left posterior cerebral arteries, not cerebellar, cerebral arteries. So we have the anterior cerebral artery from the internal carotid artery, and we have the middle cerebral artery also from the internal carotid artery, and we have the posterior cerebral arteries from which was one of the terminal branch of the basilar artery, which is from the vertebral artery. The basilar artery gives the following branches. We have the anterior inferior cerebellar artery, AICA. Of course, this is the anterior inferior cerebellar artery. قبل شوية ذكرنا بأنه عندنا posterior inferior cerebellar artery اللي يطلع من vertebral artery. تمام؟ So both of them are inferior cerebellar arteries, one of them anterior and the other posterior. Of course, these arteries supplying the cerebellum. So the first branch is the anterior inferior cerebellar artery. The second branch is the labyrinthine artery. Labyrinthine artery. Labyrinthine system is present in the inner ear. You know the ear anatomy. We have the external ear, we have the middle ear, and we have the internal inner ear, which containing the cochlea and labyrinthine system. So this structure within the inner ear is called supplied by the labyrinthine artery, which is a branch from the basilar artery, also called internal auditory artery, because of course it will supply the internal ear, the inner ear. And of course this labyrinthine artery is in less than 15%, it arises from the basilar artery, less than 50%. But 85 to 100% it arises from the anterior inferior cerebellar artery. You see? Less than 15% it arises from the basilar artery. In 85 to 100% is from the anterior inferior cerebellar artery. This labyrinthine artery, it accompanies the eighth cranial nerve, which is vestibulocochlear nerve, through the internal acoustic meatus. Remember the foramina, when we discussed the foramina, the skull, we have the internal acoustic meatus through which the vestibulocochlear nerve and the facial nerve pass. With this nerve, the labyrinthine artery pass to supply the labyrinthine in the inner ear or internal ear. The other branches of the basilar artery are the pontine arteries. Usually, there are more than one artery from each side of the basilar artery supplying the pons. And the fourth branch is superior cerebellar artery. Superior cerebellar artery. You know, we have the inferior cerebellar artery, and the inferior cerebellar artery we have anterior and posterior. But here, the superior is only one superior cerebellar artery. There is no anterior cerebellar, only superior cerebellar artery. The basilar artery terminates by bifurcating into the two posterior cerebral arteries. Two posterior cerebral arteries. And if you remember, we have the anterior and middle cerebral arteries arise from the internal carotid artery, but the posterior cerebral arteries arise from the vertebral artery. This picture shows you, so this simple picture shows the main arterial supply of the brain and the branches. You see, this is the right vertebral artery, and this is the left vertebral artery. Both of them arise in the neck through the opening or foramina in the transverse process, starting from the sixth cervical vertebrae and ascends and enter the foramen magnum. Here is the foramen magnum, and it gives many branches. The first branch is the posterior inferior cerebellar artery, PICA. The second branch is the anterior spinal artery, and as we said, a branch from the right vertebral artery and another branch from the left vertebral artery. They fuse together to form one artery, and this descends along the anterior aspect of the spinal cord, giving close supply to the anterior two-thirds of the spinal cord. Anterior two sections, two-thirds of anterior two-thirds of the spinal cord. Here, of course, not present in this picture, we have another branch which descends along here, which is called posterior spinal artery, one on the right and another one on the left. So the first branch is the posterior inferior cerebellar artery. The second branch is the anterior spinal artery, and of course this is from fusion from junction of two branch from the right and from the left. They unite together to form the anterior spinal artery. And also we have here, not present in this picture, we have another branch which is called posterior spinal artery, which descend on the posterior aspect of the spinal cord, one from the right and one from the left. And of course this right and left, they join at this area, and this area is exactly the junction of the pons. Here is the pons and the medulla oblongata. Here is the medulla oblongata. So at the junction of the medulla oblongata with the pons above, here both vertebral artery unite to form another artery which is called the basilar artery. This is the basilar artery. And this basilar artery will give us these branches. The first branch is the anterior inferior cerebellar artery. So the posterior inferior cerebellar artery from the vertebral artery, and the anterior inferior cerebellar artery from the basilar artery. Of course, this is on both sides, on the right and on the left, and these two arteries will supply the cerebellum. This will supply the cerebellum. Other branch is the labyrinthine, and this labyrinthine take a long course like this here to reach the internal acoustic meatus and enter the internal acoustic meatus with the eighth cranial nerve to supply the inner ear, labyrinthine of the inner ear. The other branches are the pontine arteries, and of course you see many branches from both sides, from here and from here, and these arterial branch will supply the pons. Here, before it reach the midbrain, it give the superior cerebellar artery. Before it terminates, before it ends, before it reach the midbrain, here is the midbrain, the basilar artery will give superior cerebellar artery, and then it ends by bifurcation into these two terminal branches اللي هي posterior cerebral artery. Posterior cerebral artery. Okay. Now, this system is called vertebro-basilar system. You know, this will give blood supply to the posterior aspect of the brain, including the cerebellum and pons and medulla oblongata. So it is called posterior system, or is called vertebro-basilar system. And of course, anteriorly here we have the internal carotid system or anterior system. Now, as we said that these arteries, the vertebral arteries and the internal carotid arteries, it forms anastomosis between them, between these branches. And this anastomosis, as a result of this anastomosis, we will get the circle of Willis. The circle of Willis, which is anastomosis between the vertebro-basilar system and the internal carotid system. Now we'll discuss and we'll show you the picture of this arterial circle of Willis. The terminal branches of the vertebral and internal carotid arteries all anastomose to form a circular blood vessel, which is called circle of Willis. There are three main paired constituents of the circle of Willis. ما هي الشرايين اللي تكون لنا هذه الدائرة أو دائرة ويلس؟ حقيقة عندنا ثلاث شرايين يمين وثلاث شرايين يسار. 3 arteries and 3 on the right and on the left. These arteries are the anterior cerebral arteries. أولا, the anterior cerebral arteries, which are the terminal branch of the internal carotid arteries. Second, we have the internal carotid arteries, which is located immediately proximal to the origin of the middle cerebral arteries. So, anterior cerebral arteries, internal carotid arteries, and the posterior cerebral arteries. And of course, as we said, that the posterior cerebral arteries are the terminal branch of the vertebral arteries. To complete the circle, these are paired arteries, right and left. To complete the circle, حتى تكمل عندنا الحلقة، حلقة ويلس، two connecting vessels. نحتاج إلى وعاءين أو شريانين يربطنا these paired arteries to form this circle of Willis. Communicating arteries or connecting vessels are the anterior communicating artery anterior communicating artery which connect the two anterior cerebral arteries, and the posterior communicating artery, which is a branch of the internal carotid artery. This artery connects the internal carotid artery to the posterior cerebral artery. Here the picture will show you, will simplify what I said. You know, this is the internal carotid artery, of course, and we said البرانش of the internal carotid artery، وذكرنا بأنه أول برانش هو الophthalmic artery، وعندنا anterior choroidal artery. These arteries has no relation with the circle, of course, in the formation of the circle, but we have this artery, this branch of the internal carotid artery, which is called anterior cerebral artery. This is the anterior cerebral artery that supply the anterior part of the brain, the frontal lobe, and part of the parietal lobe. And also we have from this, of course, this is the middle cerebral artery. This is the middle cerebral artery. And here from the internal carotid artery, we have the communicating, which is called posterior communicating artery, connecting the internal carotid artery with the posterior cerebral artery, which is one of the terminal branches of the vertebral or the basilar artery. Here between the anterior cerebral artery of the right side and the anterior cerebral artery of the left side, we have another small vessel here connecting these vessels. So the blood can pass from here to here to here. This is free connection between these vessels. And this small artery that connects the two anterior cerebral arteries is called the anterior communicating artery. So we have two communicating arteries. The anterior communicating artery connect the anterior cerebral artery on one side with the anterior cerebral artery of the other side. And the other communicating artery connect the internal carotid artery with the posterior cerebral artery, which is one of the terminal branch of the vertebral artery. So by these two communicating arteries, the anterior and the posterior, the circle of Willis will be formed. You see? So here the blood will pass freely between the carotid, the internal carotid system that supply the anterior and middle part of the cerebrum, and with the vertebro-basilar system which come from the vertebral artery. You see how much the anastomosis between the two system happen, and of course this circle is called circle of Willis. Now, lastly, we have the regional blood supply of the cerebrum. There are three cerebral arteries actually, the anterior, middle, and posterior. As we said, the anterior and middle are from the internal carotid artery. The posterior cerebral artery is one of the terminal branch of the vertebral artery. So the cerebrum supplied by both the internal and vertebral arteries. They each supply a different portion of the cerebrum depending on its location, depending on its position. These cerebral arteries will supply the area that present nearby this artery and its branches. So the anterior cerebral arteries supply the anteromedial portion of the cerebrum. The anteromedial portion of the cerebrum. The middle cerebral arteries are situated laterally, so they are supplying the majority of the lateral part of the brain. And the posterior cerebral arteries supply both the medial and lateral parts of the posterior cerebrum. medial and lateral parts. See, this picture will show you this distribution of the blood supply to the brain. So this in the yellow color, the anterior cerebral artery. This is the distribution of the anterior cerebral artery. Of course, this is the medial view and this is the lateral view. You see the medial, mainly the medial part of this part. This is the parietal and the frontal lobe, parietal and frontal lobe, medial part of the parietal and medial lobe, and part, of course, here, just small area of the upper cerebrum, supplied by the anterior cerebral artery. And the middle cerebral artery will supply most of the lateral part of the cerebrum. Most of the lateral part of the cerebrum. Of course, here we have part of the frontal, part of the parietal, temporal lobe. All this area, lateral area, supplied by the middle cerebral artery. And lastly, we have this blue color area. This is supplied by the posterior cerebral artery. Posterior cerebral artery, this is the lateral, and here from the inner or the medial aspects of the cerebrum. So these three branches or these arteries, cerebral arteries, the anterior, the middle, and the posterior, will cover all part of the cerebrum. Of course, here we talk about the cerebrum, and the cerebellum is supplied by the vertebro-basilar system through the vertebral arteries and the basilar artery. Thank you very much.